Here's a few questions that some students have asked on how to solve. This particular one, I need to simplify this radical expression. If they both have cubes on them, that means that I could use that one rule that says if they're both cubes, I just find the product of what's inside. So I can write this as 3x squared y times 36x, all under the same radical. I forgot the index, that should be a 3. Then I can simplify some stuff inside there. So I'd have cube root, like 3 times 36 is, I think, 108. But maybe I'm going to write that as 3 times 9 times 4. So 9 is 3 times 3, and 4 is 2 times 2. And then I have x squared times x, or x cubed, and a y by itself. Okay, so this is actually 3 cubed, so I could bring that out. I could rewrite this as the cube root of 3 cubed times the cube root of 2 squared times the cube root of x cubed times the cube root of y. So just using that opposite rule that we used to combine them. Now the cube root of 3 cubed is just this number here, 3, times cube root of 2 squared. This isn't a cube, so I can't do anything with that. So I have to leave that like that. So it would just be 2 squared, or we'll call it 4, times cube root of x cubed. These cancel, so it would just be an x. This one, there's not a y cubed there, so this one we're stuck with. Now what I can do is I can collect the things, or rewrite the terms, using associative property, where instead of writing it this way, I'll put all the cube stuff at the back. So I'm going to write 3 times x times the cube root of, the stuff that got stuck in was a 4 and a y. So that would be my simplification. Here's another similar question, but we're finding a quotient this time. But I could do the same thing. Maybe I'll do this one slightly differently. I'm going to separate it again, so I'm going to find the 8th root of m to the 16th. I'm going to find the 8th root of n to the 24th divided by the 8th root of 2 to the 8th. I see 8th root of 2 to the 8th immediately on the bottom there, that's a 2. Now on the top, this should be m squared. I'm not sure if you can see that, but you could rewrite that as the 8th root of m to the 8th, no, m squared to the 8th, right? 2 times 8 is 16, so I didn't change anything there. But if this is an 8 and that's an 8, then they cancel, leaving me with just an m squared on the top there. A 2 here. Let's do the same thing with this one. That would be the 8th root of n cubed to the 8th. And I got that because 3 times 8 is 24. Just so happens I have an 8th root, that's why I put that one there. Those two will cancel, so this would be m cubed. So that would be the simplification of that one. Here's a couple more questions that are in this section for the exam. This one here is an equation, and I'm asked to solve for x. So I see I've got to get a common denominator. First thing I'll do is factor, whoops, that's a plus. I'll factor all the denominators. And it looks like the only one I can factor is this one. So it'll be 12 over x times x plus 2. And then look for my lowest common denominator. So it needs to have an x plus 2 in it. Okay, it needs to have an x just by itself in it. And it needs to have an x times x plus 2. Oh, I already have that. So this is my LCD. So I need to now take each term of this expression. So I'll rewrite it. So 3x over x plus 2 plus, I'm leaving some room, 6 over x plus, oh no, equals 12 over x times x plus 2. I'm going to take each one of those terms and multiply it by this LCD. That's the I hate fractions rule. So this one, and this one all get multiplied by x times x plus 2, x times x plus 2, x times x plus 2. In this first one, the x plus 2's cancel, so I'm left with x times 3x, or 3x squared. This one, just the x's cancel, so I'm left with 6 times x, or positive 6x, plus 6 times 2 is 12, equals. Careful with that one. If this was a subtract, then you'd have to apply that negative to both things inside too. Okay, x plus 2, oh, the whole thing cancels, so that's just equal to 12. So now I can solve. It's a quadratic, so I'll bring everything over to the left, so 3x squared plus 6x plus 12. And what I'll do is I'll subtract 12 here to get that a 0, and I have to subtract 12 there to get a 0. So this is equal to 0. Whoops, I forgot to subtract a 12. So when I subtract that 12 take away 12 is 0, so I can just leave it like that. Now I factor this, so I can take a 3 and an x out, leaving me with x plus 2 is equal to 0. So I've got a 0 property. This times this equals 0. One of them's got to be 0. So either 3x equals 0 or x plus 2 is equal to 0. So in this case, x is equal to 0. In this case, x is equal to minus 2. At this point, I'm feeling awfully good because that was a whole lot of work. But I need to check each of those answers in the original question to see if they give me a 0 on the bottom of a fraction. If they do, I have to toss them out. So let's check 0. If I put a 0 right there, that's a 0 on the bottom of the fraction, won't work. So I got to go and cancel that one out. So this one doesn't work. A negative 2, let's see what happens if I put a negative 2 in there. Negative 2 plus 2, if I put a negative 2 right there, that gives me a 0 on the bottom. I can't have that either. Darn. So this one doesn't work either. Therefore, if neither of those work, you'd say no solution. Okay, let's look at a radical equation or two. Here's one. To solve this radical, I need to isolate the radical, already isolated. Notice this one down here, the radical's not isolated. I'd have to move that 4. But this one, it's already isolated, so I can take this side. Since this is a square root, I'll square this side. Do it on one side, do it to the other side. So the square root and the square cancel, leaving me with that. 2 squared is 4. Now I solve it like any other equation. I'll add 5 on both sides. So 2x equals 9. And then I'll divide both sides by, whoops, I was getting ahead of myself. Divide both sides by 2. So it'd be 9 halves or 4 1/2. Okay, this next one's a little bit more interesting because I have to isolate the radical. So I'm going to subtract 4 on this side, subtract 4 on that side. So square root of y minus 1 is equal to a negative 4. Same as the question right above, I need to take this and square it, this and square it. On this side I get y minus 1 equals positive 16. If you ever have a square root and you're squaring a negative number here, trouble. Not every time, but lots of times. Okay, add 1 to both sides, so I'll get y is equal to 17. Feeling good. Now let's check it. So if I take the square root of y minus 1 plus 4 equals 0, and if I plug a 17 in there, 17 take away 1 plus 4, is that equal to 0? Whoops. Is it equal to 0? 17 minus 1 is 16, square root of 16 is 4, but 4 plus 4 is not equal to 0. Therefore, that solution down there doesn't work. Again, on this one, I would say no solution. Okay, hopefully that helps you with those questions.